All right, let's see. So it's been a couple of weeks since the last meeting, but it's also the summer, which means things are a little slow. We've got a couple of new pull requests, both from the RGW folks. One is a PR from Eric that improves RGW ordered list map efficiency. I think if I remember right, it's avoiding a second iteration through the list or something. So that's fantastic. And then there was another one about D3N cache changes from upstream. I'm not quite sure what that is, but looks like it's being reviewed and tested, so that's good. Let's see. We had a couple of PRs closed in the last 2 weeks. Two of them are from Majian Peng related to BlueFS. Those are both, I think, minor improvements in different ways. I've got a pull request for the MDS that merged. I had opened that, I think, last week, but it's basically just a fix for cache trimming when you have lots of subtrees. We previously were iterating over the entire list of subtrees to calculate the number of subtrees, but in reality, we already stored that in a variable, so we didn't need to redo that work, and that just avoids redoing it. So it's actually fairly substantial when it happens, but it may not be that often. So anyway, that got merged. And then there was another PR that merged regarding Ceph ADM that creates OSDs in parallel rather than creating them one at a time. So as you might suspect, that's a fairly substantial improvement for Ceph ADM. There was only one other PR I saw that got updated, and that was another one from Majian Peng about enabling RocksDB pipeline to write. He had responded to a question I had regarding performance. It looks like in master now, where we have BlueFS buffered IO disabled, it probably yields a modest performance gain, but it's still probably overall a long-term win. So probably worth doing once it's all verified and tested and reviewed. That's all I had for updated and new PRs this week. Was there anything I missed from anybody? All right. Well, maybe before I get into the work that Radek and I have been doing on buffer list ring buffers, are there any topics that folks would like to bring up this week? All right. Well then, Radek, would you like to explain your ring buffer and what you've been doing?
Well, we're actually working on that together. I can go. Everything began around the IO500, around the costly encoding for in MDS detected by the IO500 testing. It turned out that the encoding is costly because of the allocations performed by buffer list. Those allocations are actually an offspring of the fact that MGS don't use the DENK framework of Bluster. It was initially developed for Bluster. It uses the old encoding stuff, which means that there is no pre-processing, there is no reservation passed to buffer list that would allow to allocate memory in one single go. And as a result of that, Buffer list from time to time really needs to go to the tcmalloc. But tcmalloc turned out to be extremely costly in that particular case. We saw in the profiles that the reason for that is actually exhaustion of the per thread cache. And as an alternative approach to switching MGS to Denk, which turned out to be pretty viral, we started experimenting, started poking with a try to actually lower the costs of allocation in buffer list. To squeeze the overhead imposed by tcmalloc, and that's the role of the ring buffers Mark has mentioned just before. Overall idea is to have a dedicated, something like actually a slab allocator that would allow to allocate big chunk and big chunk of contiguous memory and actually fragment it over, share it over the buffer row instances. Buffer row are the guys responsible for storing the physical data in buffer list. And basically, when it comes to the concept, not sure whether I can add more. Currently,
go ahead, Radek.
We are managing the allocation at the moment using extremely dumb, extremely simple idea. Circular ring, a circular buffer, a ring. It's because we need to deal with one pretty nasty thing of buffer list. It allows the allocations to be performed from a separated thread, different one than the one who made the allocation. And because of that, we got some extra complexity. But well, still trying to fight it. And what we got is actually pretty interesting drop in the usage of CPU. The MD submit thread of MDS, the dedicated, the specific instance responsible for doing journaling, actually dropped significantly. Now we can see it's mostly waits on some other, likely on some lock. But we are going further with testing. Mark made a lot of runs showing, and they showed that really huge amount of memory flows through the rings. And now we are trying to judge how wasteful buffer list really is. And why counter for that? When you are appending to a buffer list and it lacks, it has no underlying, it has no memory available. The memory for appends is exhausted. It goes and allocates in 4K, almost 4K units. And that might be really wasteful in scenarios when somebody appends just a few bytes to buffers. We are trying to estimate the waste there. But still, it's work in progress.
I put in the chat window a link to a spreadsheet that we're looking at that shows when Radek had mentioned data flowing through the ring. This is kind of what he was talking about. This is like basically when you look at the MD test easy results, it's like a 5-minute test. And then by the time you get down to the hard write results, all tests together have been running an aggregate for maybe about 25 minutes or so. Probably an hour or so, just about 25 minutes. And we're seeing sometimes up to hundreds of gigabytes of data flowing through the rings. And this is just for the metadata journaling in the MDS. It's not even data flowing through the OSDs or anything. It's just that portion for the MDS. So it's a little crazy. One thing, Radek, that I'm thinking here is that there's this tension, right, between what we're doing, where we're making these bigger allocations up front to fill in for the buffer list that don't get used necessarily, and versus the extra CPU overhead that's caused by not doing that when you have to do more work, especially in the ring, right? When you're doing lots of small allocations. But I wonder if this benchmark is not really showcasing the real behavior very well, because maybe when you have all of that memory wastage and you have to go back to the tcmalloc central pre-cache, you can't use thread cache anymore. Maybe that's work that we're not really capturing in the benchmark.
Definitely not. Benchmark is single-threaded, so no way to no way to allocate on one thread and free memory on different.
Yeah. So even though in the benchmark it looks much better to be doing the upfront larger allocation that then we can use for future things. Maybe in reality it's not as good as we think.
Sorry, got a glitch.
Yeah, I was just saying that maybe the current behavior is not as good as we think.
Well, that's quite likely. That's quite possible.
With the yeah.
Just take a look on std vector, how it allocates memory. We are very different from it. We are always, even if somebody wants to append one single byte, we go and allocate 4K chunk. Always. Yep. That doesn't make huge sense, I believe. It might be really worth to spend some time and try and implement dynamical growing of the allocation unit, depending on the history, depending on for instance, on the data stored inside buffer list.
I was really surprised at how when we're doing we're making allocations the traditional way by using the however we calculate ALEN here, the Ceph buffer alloc unit size. So then it makes sense we're doing like 4K roughly allocations, but when we don't do that, it drops all the way down to 192 bytes. And I'm very curious and this is just in this MDS test case, right? But I'm very curious how often that happens in other parts of the code as well.
Yeah, that's good question. What I can recall from the history of buffer list is that many years ago we introduced a concept called Append Buffer. It was an optimization to amortize the costs of allocations made during on appending to buffer list. And the big alloc size is actually, I think it was defined there. But I don't know why, I have no idea why it's so big. I don't know, maybe there is a good reason related to file store that is absent in Bluster. I have no idea, really. Maybe the usage scenario of buffer is just changed. Maybe we should reevaluate the allocation policy for small appends.
Yeah. I have a feeling that we probably didn't think it was too bad in terms of wastage, but in reality, it's actually quite bad, it seems.
I won't be surprised if you are wasting 70, maybe even 80% of memory.
Yeah. And if it was just memory, right? If all you were doing was wasting memory, okay, fine. This trade-off between CPU and memory, fine. But because of the way that our allocation patterns work and that we're multi-threaded, it's not just wasting memory. Now it's also wasting CPU. So you gain CPU, but you waste CPU too.
Yeah, TCmalloc and free from different threads. That can be costly. And I bet it might be actually a typical pattern when, let's say, a TP-USDTP makes some processing, makes the encoding, but finally those buffers are freed in, let's say, Messenger, handling the Messenger worker thread, handling the out queue. But on the other hand, I cannot recall such when I was tracing OSD last time. Okay, it was a long time ago, but I haven't noticed things like I haven't noticed traces like in the MDS case.
Well, in BlueStore it's using Denk, right?
Right. So it's quite likely that most of the marshalling is likely performed with the reservations.
Mm-hmm. Radek, I imagine we don't have a really good sense of how often buffer list is used only within a given thread versus when it might be freed from separate thread, do we?
I don't think so.
Yeah.
But we could get such numbers.
That was something Matt was interested in. Not in that was one of the things that he was interested in looking at, just in how much cost we were paying for all the atomic increments and decrements.
Yeah, I was just thinking the same thing. Right, you were saying it was when you were just annotating the raw TLS destructor, you were seeing 50% of the time spent in that single atomic exchange?
I think so. I will confirm that in a second, but I'm pretty sure I saw it. Maybe I have to trace.
Well, Adam, in any event, that might be a good hypothesis that's something that we should be looking more seriously at.
One second. I think I've got it. Allocate. Okay, 58% of time of cycles burned in the raw TLS allocate was on that. Pasting.
Oh, on allocate. Raw TLS allocate, okay.
Exactly. So the self is smaller than in case of raw TLS create. And in this testing, it was looking 5% of cycles.
Okay.
So 50% of that, we are burning on single instruction 2.5% of all cycles burned by the micro benchmark.
Okay. I just posted the perf call graph that I gathered from looking at the basically the caching implementation, Radix caching implementation, and this is the case when we are just requesting what we need rather than the rounded up to whatever that constant is or whatever, the Ceph something something. So Radek, you had said that in your case you were seeing that raw TLS create was taking 5% of the overall cycles. Oh, oh wait, no. I was gonna say I thought we lost Radek, but maybe not. Are you still here, Radek?
Sorry, I was muted. Sorry.
Oh, no worries.
Okay, I said that. Okay, this was in 5% was from the Append bench test, not from the Append whole bench, which is supposed to exaggerate the refilling path.
Yeah.
But on the other hand, it's a micro benchmark, so it's single threaded. In OSD or in MGS, I bet it could get worse because of increased cost of atomic operations. If you share memory, if you share cache line between many CPUs.
Yeah. I was just trying to get a sense of whether or not if you were seeing similar distribution of cycles in your tests as I am in the one that I just posted.
Sorry, would you?
In chat window, I pasted the thing I showed you earlier.
I see. From the output from perf.
Yeah, exactly. The call graph. I was just curious because you had mentioned 5% was overall was in raw TLS create, I think, right?
No, ring cache T : allocate.
Oh, okay. So mine was a little higher. Mine was like
7.19.
Yeah.
But it was spread by, it was small, it looks smashed in multiple places.
Well, I suppose we've probably exhausted all the things we've got so far, right, Radek?
I think so.
Yeah. All right. Well, that's it for now, guys. We're still working on this. Still have a lot to do, I think, but hopefully we'll make progress and be able to long-term goal, right? The real goal here is to be able to make buffer list and specifically encoding and decoding faster without actually having to change all of the existing encoding decoding over to Denk. So I don't know. We'll see. Maybe we'll have progress, maybe not, but that's the goal.
Yep, it's experimental thing.
Yeah. All right. Well, anything else, guys, or is that it? All right then. Well, have a great day, everybody.
Thanks. Same for you, and see you tomorrow or today.
Yeah, sounds good. See you later. Bye.
See you later. Bye.